Welcome back to the Architecture Corner.
Hey there.
Today we're trying to pull back the curtain a bit on something that, well, it keeps a lot of us building modern software systems up at night.
Oh, yeah. What's that?
Forget just shipping the code, right? How do you actually know what's going on inside those incredibly complex systems, especially, when they're spread out all over the place?
The classic black box problem, isn't it? You build this amazing, intricate machine of services.
Yeah, like a Rube Goldberg machine.
Exactly.
Yeah.
And you see stuff go in one end, something comes out the other,
Mhm.
hopefully. But if it jams up somewhere in the middle, you're often just guessing where the actual problem is.
Totally guessing. And as these systems get bigger, more distributed, and honestly kind of more fragile because everything's connected, that guessing game gets really difficult, maybe even scary,
Mm-hmm.
terrifyingly difficult sometimes. And that's really the challenge observability is trying to tackle. Right. And today we're looking at a really interesting article that dives into this. It talks not just about what observability is, but the how, and maybe more importantly, how to approach it with a sort of domain-oriented twist.
Okay, interesting. So not just the tech, but maybe the why behind the tech.
Kind of, yeah. So our mission today is to try and help you cut through some of that complexity. We'll explore why it's actually so hard to see inside these modern systems.
And then dig into some, hopefully, practical ideas
Yep.
from the source material, ways to make it more manageable. Maybe even, well, I hesitate to say it, delightful.
Delightful observability. Now I'm definitely intrigued. Okay, let's start with the basics. What even is observability when we're talking software systems? The article had a pretty clear definition.
Yeah, it boils down to this. Can you understand the internal state of your system just by looking at its external outputs?
So you can't crack open the box in production, obviously.
Right. No peeking inside directly.
Right.
But you can figure out or deduce what's happening by watching the signals the system gives off.
Okay, signals. Like what kind of signals? Traditionally, there have been like three main types, right?
Exactly. The so-called three pillars: logs, metrics, and traces.
Logs. Okay, those are probably the most familiar. Anyone who's ever debugged anything knows logs. They're like diary entries, right? Capturing a specific moment.
Yeah, discrete events. User X did Y at Z time, or, uh-oh, database connection failed, often with extra context, a payload of info about what happened right then.
Gotcha. And then metrics.
Metrics are different. They're about measurement over time, numerical values, think CPU load, memory usage, how long requests are taking, error rates per second, stuff you graph.
Right, the things you put on dashboards and set alerts for. Your KPIs, basically.
Exactly, your key performance indicators.
And then the third one, traces. The article really emphasized that while logs and metrics are foundational, traces are kind of the essential newcomer, especially now with microservices and distributed stuff. What does a trace actually show you?
A trace shows the journey. It's the end-to-end path of a single request or a single operation as it flows through all the different parts of your system.
So across potentially many services, databases, message queues, whatever it touches.
Yeah, all the components involved. It links together the individual steps of that one operation across all those different pieces.
Okay, let me see if I got this. Logs are specific events, like snapshots. Metrics are measurements over time, like graphs. And traces. Traces connect the dots for one single operation as it moves through the whole system.
You got it. That's a good summary.
So why has that last one, traces, become so incredibly important now? What changed?
Well, distributed systems, they just fundamentally changed the game when it comes to debugging and understanding what's going on.
Right, let's contrast that. Think about the good old days, relatively speaking, of monoliths.
Oh, yeah. In a monolith, if a user clicked a button and something went wrong or was slow, that whole operation usually happened inside one single process on one machine.
All your logs, all your metrics, pretty much in one place.
Exactly. You could look at a single log file, maybe correlate it with a performance counter on that machine, and follow the execution path pretty linearly. It wasn't always easy, mind you, but it was contained.
It was all under one roof, basically. You had a fighting chance.
You did.
Yeah.
But distributed systems, they blow that containment wide open. That same user action, let's say placing an order.
Okay.
Now, that might involve your front-end service talking to an order service, which then talks to an inventory service.
To check the stock.
Right. And then maybe a payment service to handle a credit card,
Yeah.
shipping service to arrange delivery, and maybe a notification service sends an email confirmation.
Wow. Okay, so one click could trigger like 5, 6, maybe more separate services.
Easily.
Yeah.
And each of those could be a separate application running on different servers, maybe written in different languages, talking different ways, APIs, messages.
So that one logical thing, place order, becomes this tangled web of network calls and maybe asynchronous messages flying around.
Precisely. And that's where the difficulty explodes. If that order fails, or maybe just the confirmation email is super delayed, how do you figure out where the problem is in that whole chain?
Yeah. Was it the payment service timing out? Did the inventory service hiccup? Did the message to the email service just get lost somewhere?
Exactly. Without some way to link together all the individual bits of information, the logs, the metrics, the events generated by each of those services for that specific order, well, you're back to digging through mountains of unrelated data, trying to match up timestamps across different systems.
Which, like the article says, maybe you can do with 2 or 3 services if you're lucky.
But becomes basically impossible when you have tens or hundreds. It just doesn't scale. That's the nightmare scenario distributed tracing was invented to solve.
It's the direct antidote to that distributed confusion.
It is. Its whole purpose is to give you back that end-to-end visibility for a single operation, even when it crosses many boundaries.
Okay, so how does it actually work? If the problem is that the execution jumps between services, how does tracing manage to follow it?
The core idea, and the article highlights this really well, is all about passing context. Specifically, passing unique identification.
Like you tag the request somehow.
Yeah, exactly. Think of it like attaching a unique sticky note to the request right at the beginning, and every service that handles that request.
It looks at the sticky note.
It looks at the sticky note, adds its own information, its logs, timing data, metrics, whatever, usually called spans in tracing lingo, and crucially, it passes the same sticky note ID along when it calls the next service in the chain.
Okay, so the key is consistency. Everyone has to play along and pass that ID.
Absolutely vital. The article really stresses this. Doesn't matter how the services talk. Is it an HTTP call?
Pass the ID in a header.
Right. Is it a message going through a queue?
Put the ID in the message metadata or maybe even the body.
Yep. Or even something less common, like processing a file dropped somewhere.
Put the ID in the file name or inside the file content itself.
Exactly. The ID must be propagated reliably using whatever mechanism fits the communication style.
Because if even one service in that chain forgets or messes up passing the ID,
the trace breaks right there. The journey becomes invisible from that point on. You lose the connection, and boom, you're back to guesswork and manual correlation.
ouch. Okay, so setting up clear standards for how you pass these IDs across your whole system is like step 0 for effective tracing.
Foundational.
Well,
Absolutely.
it makes total sense. Get that standard right, enforce it, and suddenly you can piece together the whole life cycle of a request, no matter how many services it bounces through. Now, speaking of IDs, the article goes into choosing and managing them well. It mentions that classic computer science problem.
Yes, the two hard things. Cache invalidation and naming things. Though some people add off by 1 errors to that list. But yeah, naming things is surprisingly tricky. And picking the right IDs for tracing. Perfect example.
So the article suggests a specific convention, using 2 distinct IDs to help manage this. What are they?
Yeah, this is a really practical suggestion. It separates things into a correlation ID and an execution ID.
Okay, let's take the correlation ID first. What's its job?
The correlation ID is the big one. It identifies a single logical task or user request from the very beginning to the very end.
Generated just once.
Just once. Right when the request first hits your system boundary, maybe when the user clicks the button or an external system kicks off a process, this same correlation ID then travels everywhere that task goes.
So if Service A calls Service B as part of handling that task,
Service A passes the original correlation ID to Service B. And critically, the article points out, if Service A needs to retry calling Service B, maybe the first call failed, it should use the exact same correlation ID for the retry attempt. It's still part of the same original task.
gotcha. So it's the single thread stitching together absolutely everything related to that one initial trigger, that one user click, or that one incoming message.
Precisely. It gives you the complete unified view of that specific business operations journey. Now, the execution ID, that's different.
Okay, how does the execution ID fit in?
The execution ID is generated by each individual service every single time it gets invoked as part of a correlation ID.
So it's unique to each specific call.
Yes. Think of it as the unique identifier for that particular instance of a service being called. So if your order service calls the inventory service, that specific call gets its own unique execution ID. Then, if the order service turns around and calls the payment service...
That call gets a different new execution ID.
Exactly. Even though they share the same correlation ID because they're part of the same order.
What if the order service had to call the inventory service twice? like maybe once to reserve the items and then again later to confirm they shipped. Still part of the same order, same correlation ID.
Each of those two separate calls to the inventory service would get its own distinct execution ID. This lets you tell apart multiple interactions with the same service, even within the context of a single overall task or trace.
Ah, okay. I see the difference now. The correlation ID groups everything for one task or use case. The execution ID identifies each specific hop or call made within that task. That gives you much more granularity.
Exactly right. You can see the sequence, the distinct attempts, the specific calls made by different services while they're working on that overall task.
That seems like a really useful way to structure the trace data. Makes it easier to read, I bet. But the article also had a huge warning sign about these IDs, right? Something really critical about not to do with them.
Yes, absolutely crucial. This is non-negotiable. These IDs, correlation ID, execution ID, are purely for observability, for tracing, for understanding the flow. You should never, ever, under any circumstances, use them for application state.
Meaning, don't use the correlation ID as like the primary key for an order in your database.
Definitely not. Or use an execution ID to look up a user session or figure out the status of some business process. No, no, no.
What's the danger?
Well, they aren't designed for that. They don't have the guarantees you need for business data. No uniqueness constraints across business entities, no security context, no proper lifecycle management tied to your actual business objects. Using them for state would be a recipe for disaster security holes, data corruption, just utter chaos when tracing implementations change or IDs get regenerated.
Okay, so business data needs its own dedicated IDs, things like order IDs, user IDs, session IDs, managed securely within your application logic.
Totally separate. Keep the concern separate. Use tracing IDs to see what's happening, but never to drive the business logic itself.
Right, they light up the path, they don't carry the cargo or define the destination.
Perfect analogy.
Okay, cool. So we've covered the mechanics, what observability is, why distributed systems make it hard, and how tracing uses these consistent IDs, correlation ID, execution ID, to connect the dots. But then the article shifts gears a bit. It moves from the technical how of tracing to a different way of thinking about writing the code that generates all this observability data.
Right. This is where the domain-oriented perspective really comes in. It's less about how do I technically log this event, and more about how do I signal what business activity is occurring right now.
The article used inventory reservation as an example, right? In a typical setup, you might have your core business logic subtracting items from stock.
And then right there, mixed in with the if statements and database calls, you've got lines like logger.info or metrics.increment.
Yeah, the instrumentation code is just tangled up with the business code.
And the article points out several problems with that. One is just sheer volume. Sometimes the instrumentation code can bloat the business logic class. But maybe more importantly, the developer writing the reservation logic now needs to be an expert in two things.
Inventory management and the specifics of your logging and metrics system.
Exactly. They have to remember the exact metric name to increment, which fields need to go in the structured log, how to format the context. It adds significant cognitive load.
And it makes changes harder, right? If you decide to rename a metric or change your logging format.
You might have to hunt through core business logic files all over the place to make those technical updates, which is risky. You could accidentally break the inventory logic while trying to tweak a log message.
Okay, so that's the problem. What's the alternative the article proposes?
The alternative is to encapsulate the instrumentation calls in a way that reflects the business operation itself. This is where they introduce the idea of a domain probe.
A domain probe. Intriguing name. What is it? How does it work?
Think of it as a dedicated helper class. Its only job is to emit all the relevant observability signals, logs, metrics, trace spans for a specific business concept or operation. So for our inventory example, instead of putting logging and metric calls directly in your inventory service,
You create a separate inventory probe class.
exactly, and the inventory service interacts with that probe.
What would that look like in the code?
So the core inventory logic, when it successfully reserves items, wouldn't call logger.info directly. Instead, it might call something like inventoryprobe.itemsReserved, successfully ordered items reserved. Or if it failed, maybe inventoryprobe.reservation failed, ordered reason.
Ah, I see. The method names on the probe itself describe the business event or outcome.
Precisely. And all the messy details how to actually log that success, which specific metric counter to increment, what attributes to add to the trace span for that outcome, all that technical stuff is hidden inside the inventory probe class.
Okay, that immediately makes sense. The article listed several benefits for this approach. Let's unpack those. You mentioned grouping.
Yes, that's a big one. All the observability code related to inventory reservations is now physically located in one place, the inventory probe. If you need to understand what signals get emitted about inventory, you look at that probe class. It becomes the single source of truth for instrumentation for that specific domain function.
Much easier than grepping through who knows how many service files, which leads to easier changes, I assume.
Absolutely. Yeah. If you need to rename that items reserved metric or add a new standard field to all failure logs, you likely only need to change the code inside the inventory probe. The core inventory service code, the business logic, might not need to change at all.
Nice. It decouples the business logic from the nitty-gritty details of how you observe it.
Exactly. And then there's explicit intent. This is about readability. When you're reading the inventory service code and you see a call like inventory probe.items reserved successfully, it's immediately clear why that line is there from a business standpoint.
Much clearer than trying to decipher a generic logger.info order processed ordered call. It tells the story better.
It does. It tells the story of the business process through the instrumentation itself. And for the developer writing the business logic, this ties into reduced cognitive load.
Right, because they don't need to keep all the metric names and log formats in their head.
Exactly. They just need to know, okay, for inventory stuff, I talk to the inventory probe. And the probe offers methods named after business actions. They stay focused on the what of the business logic, and the probe handles the technical how of observing it.
Makes sense. Focus on the domain problem, called the relevant probe method. And the article also suggested this might lead to less boilerplate.
Potentially, yeah.
Yeah.
The probe could encapsulate common setup or context enrichment that you might otherwise repeat in multiple places in your business logic classes.
Okay, and then there was that last benefit, the one you called slightly controversial, making logging more difficult. That sounds bad for observability.
Aha, yeah, it sounds provocative, right. But there's a good point behind it. In a lot of code bases, developers kind of get into the habit of just sprinkling log.debug, kind of line 52, or
Oh.
log.info, processing request, everywhere. Sort of just in case logging.
Guilty as charged sometimes. It creates a lot of noise.
It does. So the idea here is by requiring the developer to think, okay, I need to call the domain probe, and I need to pick a business relevant method name like user logged in, or payment attempted, or item added to cart, it forces a small moment of consideration.
A pause to ask, is this event actually significant from a business perspective? Does it warrant a specific named signal via the probe?
Exactly. It encourages more intentionality. You instrument things because they represent meaningful steps or outcomes in a business process, not just because your code reached a certain point. It pushes you towards emitting signals that are actually useful for understanding how well the system is doing its job for the business or the user.
That feels, yeah, like a more mature way to think about it. Less about just dumping data, more about emitting meaningful signals. It aligns observability much closer with the actual purpose of the system.
Yeah, it helps elevate observability from just being seen as like technical plumbing to being an integrated way you understand and manage your actual business capabilities running out there in production.
Okay, so bringing this all together, this discussion really underscores that observability in these modern distributed systems, it's not just some simple add-on. It's complex, yes, but absolutely vital.
hmm And the key strategies we pulled from the article really seem to be, first, get your foundations right. Establish clear, enforced standards for those correlation ID, execution ID, across all the ways your services communicate. That's essential for tracing to even work.
Right. Consistent context propagation is non-negotiable. And second,
Second, think about how you actually write the instrumentation code. Consider moving away from scattering technical calls everywhere, and maybe adopt something like this domain-oriented probe pattern. Group your observability signals by business function.
even if you're not doing full-blown domain-driven design everywhere.
Yeah, exactly. Even just applying that idea of using probes to group instrumentation by business capability can make your observability code easier to find, easier to change, and more explicitly tied to what the business logic is actually trying to achieve.
So it shifts the focus. Less about just low-level technical events, more about tracking high-level business milestones and outcomes.
Which gives you data that doesn't just tell you if your system is up, but tells you if it's actually working and achieving its purpose.
Yeah, much more valuable.
Definitely.
Okay, so here's something to maybe mull over after our chat today. How might really thinking about the business purpose of a piece of code, what is this actually doing for the user, for the organization? How might that change the way you decide what signals, what information you need to emit about how it's behaving internally.
That's a great question. It's a perspective shift that could really change things.
Absolutely.
Hmm.
Well, that wraps up our exploration of observability from a domain perspective here on the Architecture Corner. Thanks so much for digging into this with me today.
My pleasure. Always interesting stuff.
You can find links and more details about the article we discussed in the description for this session. And hey, don't forget, you can subscribe, totally free, to the Architecture Corner newsletter so you don't miss out on future explorations like this one.